The twin spacecraft Voyager 1 and Voyager 2 have operated in space for 45 years instead of the planned 5, and they're still there, transmitting strange signals to Earth. Scientists believe we won't lose contact with the Voyagers until 2025, but will they have time to show us anything else? Is there any chance their journey can continue? The Voyager missions were initially launched to reach Jupiter, Saturn, and the major moons of both planets to photograph them. Thanks to their images, scientists were finally able to see the surfaces of the moons around Saturn, which had previously seemed to be just bright dots. That was the beginning of a series of discoveries related to one of the moons, Enceladus. Scientists were shocked by the fact that Saturn's moons showed geological activity. Moons are usually covered with craters, scars left after collisions. These craters do not disappear if a moon is stationary and there's no geological activity. On the contrary, Enceladus appeared to be smooth, like pearls. This could mean it's forming an atmosphere, and one day, life could probably originate there. Today, we know that the reason for the smoothness of Enceladus lies in cryovolcanism, which is the melted ice that covers the satellite, ensuring the displacement of ice masses and the formation of new ones. But in the 1970s, nobody was aware of this, just as they were unaware of Jupiter's moon Io. Before the Voyagers, Io seemed like a tiny ball of rock and ice at a distance of 800 million kilometers from the Sun. The legendary probes presented scientists with a different picture. There was no ice on Io, only raging volcanoes everywhere. The ash plume from the eruption of the largest of them reached a height of 400 kilometers. That was the first time active volcanoes had been seen somewhere other than on Earth. It turned out that Jupiter's enormous gravity makes the moon's tectonic structures constantly move, resulting in extreme volcanic activity and magma emissions far beyond Io's surface. The Voyagers also showed scientists Jupiter's radiation belts and the never-before-seen planetary rings. These rings were first spotted by Voyager 1 in 1979. Several months later, Voyager 2 conducted more extensive imaging, allowing rough determination of the ring structure. Then it was the turn of Saturn, the owner of the most extensive ring system in the solar system. Saturn's rings consist of countless small particles ranging in size from micrometers to meters. We know this thanks to NASA's Cassini spacecraft, which spent 13 years studying the moon. However, if the Voyagers hadn't captured the bizarre interlacing around Saturn, scientists might never have sent Cassini. The same happened with Saturn's moon Titan. The Voyagers were the first to notice liquid seas on Titan, which Cassini only confirmed 40 years later. It seemed that after 5 years in space, the Voyager mission came to an end, but fortunately, it happened otherwise. The mission was extended. Voyager 2 went on to explore Uranus and Neptune, and Voyager 1 headed to the unknown moons of Jupiter. But how could they continue the mission if they were only expected to last 5 years? The twin Voyager probes each weigh 773 kilograms, while newer devices such as the Japanese Akatsuki, released in 2010, are at least 200 kilograms lighter. Of that total weight, each Voyager carries 105 kilograms of scientific instruments, including the Imaging Science Subsystem (EISS). This consists of 2 television cameras. The first one is wide-angle with a low resolution of 200 mm, and the second camera uses a narrow-angle lens with a higher resolution of 1500 mm. However, these technologies are almost primitive compared to what's aboard the James Webb Space Telescope, which boasts a camera with several matrices, sophisticated prisms and lenses, numerous shutters, and autonomous mode. Nevertheless, the Voyagers made quite a stir. Even though, as the mission moved farther from the Sun, the objects in the photos became dimmer, the Voyagers managed to transmit hundreds of thousands of photos with a storage capacity of only 67 megabytes. Today, you'd hardly be able to make a good TikTok video with such a memory capacity. Obviously, it wasn't just about the cameras. What was it about then? Power. Each Voyager has 3 radioisotope thermoelectric generators, and the fuel used is plutonium-238 oxide. As the isotope of plutonium decays, the probe's power decreases. In 2011, it fell by 57% compared to its launch power. The remaining power would be insufficient to keep all the subsystems running for so long. That's why scientists decided to shut down some of them to save energy. This begs the question, how did the Voyagers manage to get this far from Earth? It's all about a carefully chosen launch time. Scientists took advantage of a rare alignment of the outer planets in the late 1970s. This arrangement of Jupiter, Saturn, Uranus, and Neptune occurs approximately every 175 years. This alignment allows a spacecraft to follow a particular trajectory and make a 4-planet tour using a minimum of propellant and time. This is the so-called gravity assist. When passing each planet, the spacecraft uses its gravity to increase its speed and reach its next destination. Using this technique, the flight time to Neptune was reduced from 30 years to 12. Voyager 2 was launched first, with a trajectory developed to fly past Jupiter, Saturn, Uranus, and Neptune. Voyager 1 was launched second, but on a faster and shorter trajectory designed to send the spacecraft closely past Saturn's largest moon, Titan. In the 1990s, Voyager 1 overtook the slower deep space probes Pioneer 10 and Pioneer 11, becoming the most distant human-made object from Earth. But does this mean we can keep using the Voyagers? The speed of digital data transmission between the Voyagers and Earth is constantly decreasing as the spacecraft travel further from Earth. For example, when Voyager 2 traveled from Jupiter to Saturn, the data transfer rate was halved. What can we say about fast data exchange if Voyager 1 is currently at a distance of 185 billion kilometers from Earth and Voyager 2 has flown 15 billion kilometers away, continuing to move at roughly the same speed of over 60,000 kilometers per hour? However, the distance doesn't yet prevent maintaining the connection with the devices. The Voyagers continue to search for the boundary between the heliosphere, the region of our Sun's influence, and the interstellar medium. They even send new data. Voyager 1, for example, managed to record sounds where there just can't be any sounds. It turned out that this noise occurs when the solar wind waves collide with waves coming from other stars in interstellar space. This means the Voyager mission devices help scientists get information about the interstellar medium's parameters, which can't be obtained in any other way. Researchers hope to gain enough information while the Voyagers still have fuel. However, there is a caveat: Voyager 1 seems to have gotten lost. In 2022, NASA announced that the readouts from Voyager 1's attitude control system didn't seem to match the spacecraft's movements. Scientists assume the probe is confused about its location in space. Here's how it works: the attitude control system sends data about the interstellar medium surrounding the spaceship. The signal passes through a giant antenna directed toward our planet, but now it only gives engineers random numbers that don't reflect what's actually happening on board. Scientists are struggling to understand the nature of the problem. If they fail to resolve it, we may lose Voyager 1 sooner than expected. The scientists' task is complicated by the fact that the probe is very far away. Voyager 1 signals take 20.5 hours to reach Earth, and exchanging messages between the space agency and the probe takes 2 days. There's another problem. Back in the early years of the mission, thousands of employees worked on the Voyager mission, but today, no more than 20 people work on it part-time. That's unfortunate because there's still more the Voyagers could see. When the probes run out of power, it doesn't mean they'll get stuck in zero gravity. The Voyagers use fuel to keep the subsystems running, so they'll continue to fly. But they'll stop turning the antennas in the right direction and sending signals to Earth. Currently, the Voyagers have moved beyond the influence of the solar wind, and after 20,000 years, they'll cross the Oort cloud, a swarm of comets and icy debris orbiting the Sun at a distance of up to 100,000 astronomical units. That is 100,000 times the distance from the Sun to Earth. This will be the final destination of their journey through the solar system, and although we'll lose contact with the probes by then, they'll still be silent witnesses of space phenomena. After 500 million years, the Voyagers, along with the entire solar system, will make a full revolution around the center of the Milky Way. You guys know everything in the galaxy revolves around the center. Right now, it's impossible to predict what will happen on Earth by then, but in the past, in that amount of time, the supercontinent Pangaea formed and collapsed. Scientists also assume that in its galactic orbit, the spacecraft will oscillate up and down. At the same time, Voyager 1 will oscillate more dramatically than its twin. According to assumptions, Voyager 1 will travel so far above the main disk of the galaxy that it will see stars at just half the density as we do from Earth. Besides, the same difference in vertical motion will also shape the differing odds each spacecraft has of survival. Yes, you heard me right, survival. The thing is that the Milky Way's vast clouds of interstellar dust are very dangerous. Dust will pound into the Voyagers at a speed of a few kilometers per second. Even a dust grain only 1/1000th of a millimeter across will still leave a small crater. These grains will steadily hit the hull, which can slowly chip away at the spacecraft's skin. Of course, the dust won't change the trajectory, but the gravity of the Milky Way's clouds can easily do it. The clouds have so much mass concentrated in one place that they may fling the spacecraft into new orbits, sometimes much farther out, sometimes even deeper towards the galactic core. In this sense, Voyager 1 is at a greater risk. Its vertical oscillations mean the spacecraft will spend more time above and below the galactic plane, where the clouds are thickest. But despite the potential dangers, the Voyagers will probably have time to visit another star. Voyager 1 will move to the constellation Ophiuchus, and millions of years later, the probe will say hi to a red dwarf named Gliese for 45 in the constellation Camelopardalis. Meanwhile, Voyager 2 will reach the constellation Sagittarius and visit a star named Ross 248. It could also be that the Voyagers will see stars that haven't been born yet. But why should we care whether the Voyagers will meet them if we no longer exist by that time? We actually should, because the probes carry valuable cargo destined for distant civilizations, 2 golden records with a collection of information about humanity and our home planet. They contain photos of Earth, sounds of animals and birds, and words in various languages. They also contain the location of our solar system in relation to pulsar stars and even instructions on how the record is to be played. This seemingly frivolous idea may well be the last proof of our existence because the records were designed to last billions of years in space. Under the gold plating, there's a protective aluminum cover, and beneath it, there are engraved copper discs. For additional protection of the records, they were placed on the Voyagers so that the engravings would be hidden. If the records survive, they'll last about 5 billion years, no more. Why? Because after this period, there will be the great Andromeda Milky Way collision, and the fate of the Voyagers depends on the conditions of this merger. Will they be able to survive? If the devices survive, they can live on for trillions of years. That's long enough to enter genuinely unexplored space. By that time, stars will exhaust their fuel, and the star formation processes in the universe will completely cease. The Voyagers would drift in a universe that would be absolutely unrecognizable to us, populated by black holes and the remnants of neutron stars.